Between zeros and of. Between zeros and of. There we go. All right, quick review from last week. I think, what day was it we did? Was it on Friday? Did we lecture Friday? If I give you a graph, can you tell me the x-intercepts? All right, good. If I give you this, can you tell me what the x-intercepts are? And the multiplicity. Okay, then we're actually good. Multiplicity is just the power being taken to. All right, let's do something wild then. All right. Star this. It will come up once in a while, but not too much. All it's saying is if, I'll let you guys find it. It's a mess. If a plus bi is a 0, a minus bi has to be a 0. So if I give you one of the zeros is negative 5i, what's another 0 have to be? Positive 5i. If I give you a 0 is 3 plus I, that means I also have to have 3 minus I. No matter what, because the i's have to cancel. All right, we are in 5.5. We should be on page 3-ish of it. If you're following along. All right, so that, yeah, you can factor stuff into linear components. We've done that before. Something that's interesting is if you're dealing with anything to the odd power. What do you know what odd functions look like? They look something like this, right? You all agree on that? So no matter what, an odd will have at least one 0. Do evens have at least one 0? Real 0? No. The odds have to have at least one 0. This is some definition things. Let's do this. All right, I need to take a deep breath. I covered like an hour of material. All right, factor this. We can't use grouping on this one. Grouping is not possible. We need to find the zeros. Desmos didn't show up to the party. Not yeah, Desmos doesn't give us the complex numbers anyways. Yeah, so get out of here, Desmos. But luckily, they give us this, but they give us what a factor is of it. So can I turn that cubic function to a quadratic function? Yeah. If I know this is a factor, I gave you this problem, would you guys know how to figure it out, like the division, using synthetic? So that's what you gotta do. That's step one. We synthetically divide, and then we're gonna solve the quadratic. Based on my camera, I need to see how far to the left I can go. What? You think I get a copyright hit if I played the werewolf song on the background the whole time? 1. You guys may run out of room on your notes if you're trying to fit this in boxes today. All right, what did I put in this box? A fox wearing socks? What? 3. Yeah, you guys are good. You guys got synthetic. 1. Oh, 3 times negative 2 is negative 6. That negative 24. Oh, thank goodness. What do you think should happen? If I know this is a factor, when I divide it, should I get a remainder? No. So that's good. That means I did it, right? So I can rewrite this as x minus 3 times nothing x squared. Yeah? Now it's a quadratic. Can I solve quadratics? Yeah, I can solve quadratics. What tools do I have? Oh, I didn't even do that one. All right. I can factor it. I can quadratic it, right? Those are pretty much our big two. Is this one factorable? As Winnie the Pooh once said, it is actually factorable. Is this on screen, or am I too far to the left? Jiminy Crickets. I'll just do it this way. What times what equals negative 24? 1 and negative 24? No. 2 negative 12? No. 3 negative 8? No. 4 negative 6? Yeah. Yeah. Certainly. Sorry, I'm doing the factoring really quick because we already did that. Is that fully factored from a cubic? We did it. What's it want? What are my zeros then? When x equals what? Let's list them in order from smallest to largest because that's how it's going to be on the homework. What's my smallest zero of these three? Negative 4, right? And then 3, then 6. You don't have to worry about. Do you guys remember doing that ever set notation? It's just saying that x equals any one of these three numbers. You don't have to type that in. But there, we factored it. So what's my first step? Let's do another one. If they give me one of the factors, what's my first step? Divide it, right? Divide it and then solve it in one of our other ways. What if I divide it and I don't get a zero remainder? What should I do? I would try to divide it again because it has to get a remainder 0. All right, let's do another one. Is this the one I did? Actually, I'm going to skip this one. One caveat. For this one, what would I put in the box? If it says x minus equals minus 5 is a 0, I would put the negative 5. You guys see the difference? This question is different than the other one because it's not saying that it's a factor, it's a 0. So the factored part would be x plus 5, right? Because I plug in negative 5 to get 0. That's probably the biggest mistake. If they give you the 0, plug in the 0. If they give you the factor, you use the opposite. But this one, if you want to try that one, this is one that you long divided out, and then it's factorable. So you can watch the video if you want extra practice one before you do it. So, all right. Lock in. All right. So we have a different one. I'm jumping ahead a little bit. I skipped some examples. By all means, watch the longer video. So I know x equals negative 1 is one of my zeros. Okay? So when I go to synthetically divide, what do I plug into the box? A negative 1. Plug in your 0. Now be careful. What thing do I have to pay attention to on this beast? What am I missing? An x squared, right? So I need to put a 0 there. 12, 13. All right. So we synthetically divide it. You guys mind that I do this relatively? Oh my gosh, no way. Good. I should always get a 0 remainder when I divide these, right? If they tell me it's a factor. I should probably go through and make sure everything works that way. Oh. All right. So technically, if I'm looking to find all the zeros, do you like it when I rewrite factored, or can I just put it in the back of my head? Negative 1 is going to be one of my zeros, right? How do I know that? They told it to me, right? So now what I'm going to worry about is this x squared minus x plus 13. What are the zeros of that, right? When does that equal 0? When's it a root, an x-intercept? All those things mean the same thing. This is not factorable, right? My only factors are 1 and 13. That doesn't equal -1. Uh-oh. So what do I got to do? Rhymes with Smadradic equation. I got to do my negative b plus or minus square root of b squared minus 4ac all over 2a, right? Did you guys, side note, this is, how do I find the x of a vertex? Isn't it negative b over 2a? Do you realize the first part of the quadratic is negative b over 2a, right? So you're actually using your vertex, and then you're adding to it the two zeros because they're the same distance on both sides. So if you ever forget, that part of the quadratic is from the vertex formula, because you find the vertex, and then the two zeros are on equal distance from both sides of the vertex, right? It's going to cross the same point. It is and this is from completing the square. If you do completing the square, that's the same formula every time. You can prove this really easily, actually. And in college, I didn't even use this. I always just solved it using that because I don't like formulas. I don't know why. Because probably when I was a baby, I drank too much formula. All right. Sorry. All right, so let's just plug in -1 plus or minus square root of -1 squared minus 4 times 1 times 13 all over 2 times 1, right? You're lucky I let you use notes because I can't tell you have to memorize it, although you use it a lot. So I get 1 plus or minus the square root of -51 over 2. Uh-oh, SpaghettiOs. Now, if this question was find the x-intercepts, at this moment I would be done and say we only have one x-intercept at -1, correct? Because is that a real number? No, absolutely not. Is that going to be an x-intercept or a root? No. But is it a 0? Is it something I plug into this to get 0? Yes. So I do have to respect it. I got to respect this point. What do I do with that negative? I pull out a I. Right? I pull out an I. Yarnar. So I quadratic it, negative, pull out an I. It was really painful. Waka waka. So now, of course, when you're doing your homework, what's that answer going to look like? What am I going to do with this number to make your life, like, this is paper and pencil, that'd be fine. I have to divide both these by 2, right? So technically I'd have 1/2 plus I square root of 51 over 2, right? And my other solution would be 1/2 minus I square root of 51 over 2, right? Don't be afraid of the negatives, just pull an I. If we ever have time, I have a good story if you're taking anatomy about pulling out an I. It's actually pretty wild. Technically, is there anything new in this section yet? Or is it just combining a bunch of stuff at once? Nothing new. Synthetic division, quadratic, right? And then complex. So we're combining 3 different sections. This is kind of like the accumulation of everything that we've done so far, actually. Yeah, well, if you can't stuff your stuff inside of a stuff, and then your bear loses its stuffing. And then Thanksgiving, you forget to make the stuffing. Except, all right, this is the very new thing, okay? You guys need to lock in for the next probably 15 minutes because what I'm going to show you is going to be very, very new. And actually, if anyone's planning on taking pre-calc next year sometime, this is usually in there. So, what if they don't tell me what one of the zeros is? Do I just ask ChatGPT? No. No. Do I ask Chat Mr. T? Yeah, well no. what I do is this is called the rational zeros theorem. You don't need to know the name of it. But given a giant quadratic, I can list my zeros by doing B over C. Now, this is why I really dislike why the letters they use with B over C. When you see B over C, you're thinking a quadratic, right? And you're thinking of B and C. That's not at all what they mean. B is a factor of your last thing, and C is a factor of your first. So I'm going to give you a little bit different notation, one that a different textbook I learned from did. They called it P over Q, where P, make sure I tell you right, where you have your P and your Q, okay? The only reason I would suggest, I usually don't use capitals, that you do it this way, or if you want to do it this way, it won't match up the video. But one of the reasons why you may want to do it is if you can't get over the fact that B and C are used for a different formula. Like I said, our textbooks for pre-calc, you call it the P over Q method. Okay? Both ways are fine, whatever floats your boat. The biggest thing, honestly, you just got to know is you factor the front term and the back term. And right now, that probably means, this means absolutely nothing to you, right? This is just a lot of letters on a board. Let's quantify it. So we did P over Q, right? Do you guys want to stick with P over Q or use the B over C? Or do you not care? Are you just here to follow along? And I'm just here so I don't. So P, on this problem, which one's my P? My P is my last term, and my Q is my first term, okay? So what does it mean to be a factor of it? What are all my factors of -8? So think about -8. What times what equals -8? Could I do -1 times 8 and 1 times -8, right? What about -2 and 4 and 2 and -4? You agree on that? So those are all my possible factors Those are all my possible factors of my last term. If I break it down, those are everything it's going to be. Okay? Again, I want to reiterate, this problem's going to take a long time, but every step is something we can do, right? Can you tell me what times what equals -8? Yeah. What times what equals 1? 1 times 1. What else can multiply? Because I'm looking at my Q now. It's a 1. What else times what equals 1? -1 and -1. So I get 1 and -1 are my Q's. We're almost there. We're almost done with, well, kind of. Now, what I want to know is P over Q. What are my only two factors of Q? Are they both 1 and -1? But we already have the number and its opposite, right? So if I divide all these by 1 and then divide them all by -1, I get the same set of numbers twice. You guys see that? Now that's important because if you're ever given a problem with a 1 in front, guess what? You're only really looking at your Q or your P, your last term. Okay? Because when I divide these, -8 divided by 1 and 8 divided by 1 is -8 and 8. But then when I divide them both by -1, I get -8 and 8. So I don't have to do it again. Okay? Ta-da. So those are the only possibilities I have for a 0 for this function. Would that work for quadratics too? Yeah, do you guys remember when you did factoring a long time ago, you did the slide and divide method? Do you remember that, slide and divide? That's this. That actually isn't a shortcut. That's doing the P over Q. You're doing your P times your Q, and then you're finding, you know what I mean? Like, it's an actual way to solve it, because then at the end you divide by your Q. So when you do slide and divide, it feels like a trick, but you're actually using higher level math to do it. Would this work if it was x to the 10th power? Yeah, it does. It works with any polynomial. So now what do I do with these? I know, since that's not, one of these has to be a 0. One of them has to be a 0. How do I find out which one's a 0? This is where it gets really tedious. This is where on your calculator, you guys know the second enter. If you hit second enter, what does it do? Second enter, it takes your equation you plugged in and it plugs it all in again, and you can change the numbers, right? Because what I'm going to need to do is this. What's f of negative 8? Negative 504. Is that a 0? No. What's f of 8? 360. Is that a 0? Again, if I'm doing my homework, can I use Desmos and set the equation and change my x value? Yes. Can I use my calculator and hit second enter and re-plug in my x value? Yeah, this takes way less time you think it does to do it, but it is tedious. What's f of 4? It's 0. F of 4 is 0. So what's that mean that 4 is? 4 is one of my zeros. Are you guys going to take my word on this? I'm going to go through and I plugged in all the numbers. I'm going to plug them all in because f of negative 4 was not 0. Do I care what it actually is? It's not 0. F of 2 was not 0. And f of 1 was not 0. Doesn't matter what they are. No. But now hear me out. Am I done with this problem at this point? For this one, I am. How many zeros can an x to the third have at most? 3. How many zeros did I find? 3. So what are my zeros? 4, negative 2. Oh, let's write it in order. Negative 2, negative 1, and 4. And I'm done. I don't have to factor. I don't have to quadratic. I don't have to graph it. Again, how do I know they're zeros? Because when you plug them in, you get 0. Again, factoring, right? Evaluating, plugging it in. Is there any, we covered all that stuff when in the first unit, right? The problem, it just takes a while, right? What's the good news about these problems? The good news is you're done if you get 3 zeros. But what happens if you don't get 3 zeros when you do it? Then what happens? Then what do you do? Then you have to do some harder math. All right, let's try it. Well, actually, do you guys want to? I'm not going to do this full problem. I might, though. It might be helpful. It might. Do you guys want to try this one, then go over it? We got to do this one. We absolutely have to do this one. Gulp, gulp. Yipers, folks. All right. How do I do it? We're doing P over Q, right? Before I do that, what are my P's? What are my Q's? And why do I need to mind them? So for p's, I'm looking at 6, right? What times what equals 6? 1 and 6, -1 and -6, 2 and 3, -2, -3. Y'all see how I did that? All right. So we got -6 and 6, -3 and 3, -2 and 2, -1 and 1. Good. What do I got in front of this x to the cube? The 1, right? Again, luckily, I have -1 and 1, right? I will not give you a problem with a number in front of the x, like the highest power. Because if you do that, what does that do to my number of combinations? A lot. Like if I had a 2 up here, there would be what, 16? If I had like a 4 up there, oh no, I'm sorry, 2 would be -2. You'd have to do -2, so it'd be 3 times. There'd be 24 different numbers to try in. So when you get to that, you don't use P over Q because it's not worth it. So now luckily, last time when we just had these ones, do I really worry about when I divide it? Or can I just, it's going to be the same numbers, right? Same numbers. Yar? What do I do with those numbers once I find them? Plug it in. Plug it into P, right? So I'm going to do P of -6 is not 0. P of 6 is not 0. Again, I know I keep saying it, but on your calculator, learn the second enter function or to push up, because then you're just plugging in stuff again. You could do all your negatives first, plug in all your negatives, and then delete the negative, then plug in all your whole numbers, and you can get through this pretty quick. Well, P of -3 is not 0. I'm just writing this out to make sure that I show 0. I'm just writing this out to show that you should do it, because that's a lot easier than having to. Uh-oh. What? It's like when my kids spilled their food all over the carpet. I only got 1 0. Even if there's complex numbers, how many zeros should I have with x to the third? Should have 3, right? Because we're dealing with the complex world too. So we need to have 3 zeros if we have x to the third. But we only have 1. Time to quit. No. What did we do before when they gave us 1 with zeros? What did we do with the first example? We divided it out, right? So if I divide this out from that, I'll have a quadratic. Can I solve any quadratic no matter what in here? Yeah, you can always use quadratic formula, right? So let's divide it out. Get out of here, -1. Up in this box, I'm going to put a 3. And I'm going to do 1, 2, -17, and 6. You guys are okay with me going quick through this part? Uh-oh. Uh-oh. Phew. I did it right. Could I have on the other problem, once I get 1, 0, long divided it out? Or not long divided. Don't long division, please. Please, please, please. Just so you know. Other people do. So, x squared, 5x, right? That's not factorable. I know, because if it was, it would have showed up in that. So it's not factorable. So I'm going to go right to my quadratic equation. Okay? So -5 plus or minus 5 squared minus 4 times 1 times negative 2 all over 2 times 1. Okay? So it's at negative 5 plus or minus 33 over 2. Yar nar. So now, again, if you're plugging in answers for the homework, my 3 zeros would be, I'm running out of room. My 3 zeros would be, this is not in correct order. I can do it. Negative 5 over 2 minus root 33 over 2. Whatever that decimal is, right? Like you're going to have to plug in a decimal. Or you could just plug it in and do it. Negative 5 over 2 plus root 33 over 2. And then 3. Those are the 3 solutions to that beast. What do you mean, this? Yes. I'm just breaking apart how you're going to get a decimal, right? When you plug this in, you could have plugged this in your calculator and gotten a decimal, right? I'm just kind of breaking it apart. In case you have an I, get used to that, because with an I, you have to break it apart and get your decimals. This is 1, 2, 3 answers. 1, 2, and then the 3 we got from over here, right? I warned you, like, I just wanted to reiterate though. Can you factor a number? Yes. Can you plug numbers into an equation? Yes. Can we synthetically divide? Can we quadratic? What makes this problem so difficult? You have to do all 4 things, right? One problem takes 4 different units to do. This is almost like like I said, this could be pretty much the test. I could just say, hey, do 2 of these problems, and that would cover half of what we've done. Do you know what I'm saying? And this one didn't have an I in it. We'll do one with an I in it, and then there'll be 5 of the sections we did will be in one problem. Okay? You see what I said? These problems aren't, you have the tools, it's just they're extremely tedious to do. They take a long time. Wait till if any of you guys take calc, and it takes 50 minutes to do one related rates problem. Well, at least that's fun. One. I don't think I gave you any of those. I'm going to do, what time? We got time. I'm going to do one more, and then I'm done for the day. And then tomorrow, I'm going to show you how to do the 1s to the 4th using graphing to help you out. Because on the test, it's to the 3rd. On the homework, the 1s to the 4th, I want you to also be able to use a graph to take out 1 of the zeros. And I'll show you how to do that tomorrow. Sound good? And then you'll have time. Uh-oh, to the 4th, that's too much work, they said. And I say, that's okay, we'll be okay. All right, we're doing P over Q, right? My P and my Q. What are my factors of negative 1? What times what equals negative 1? 1 and negative 1. That's not too bad, huh? What are my factors of Q? That's a 1. There. 1 and negative 1. So P over Q, I'm going to get, guess what? Negative 1 and 1. So how many different numbers do I have to plug into this one? 2. I only got 2 numbers, right? Oh, no. I didn't write down which one's which. All right. So f of 1 and f of negative 1. So f of 1 would be what? 1 minus 2 minus 8 minus 6 minus 1. f of 1 would not, that's not going to be 0. Right? Yeah, that's not 0. F of negative 1, that become a plus. That becomes a plus. That is 0. All right. So I know one of my zeros is negative 1, correct? Calm down, computer. So I'm just going to put it down here to remember negative 1 is one of my zeros. So then I'm going to synthetically divide it. 1, negative 2, negative 8, negative 6, negative 1. Whoa, 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 whoa. Sorry, man. This is just my favorite thing. Yeah. Hold on. I went too quick. I got to take a deep breath. That's negative 3, 3, 5, negative 5. What did I do wrong? Wait, did I do? That should have been negative 5. Yep. There we go. I tried to slow is smooth and smooth is fast. Slow is smooth and smooth is fast. All right. So I get x cubed minus 3x squared. Uh-oh, SpaghettiOs. I can't factor that. Wait, can I? No, I can't. So what do? I do this again. Right? Because look, I got rid of one of my zeros, right? Another one has to exist, but what are my P's and Q's again on this one? Are they the exact same? Mamma mia. Let's call this one, what's your guys' favorite letter? Let's call this P of X. Let's do P of negative 1 and P of 1. P of 1 is not 0. P of negative 1 is 0. Wait a second. You're telling me I can pull negative 1 again? Yeah, that's exactly what I'm saying. Because remember multiplicities? Sometimes zeros exist more than once. Like me. That wasn't very nice. You shouldn't call yourself a 0, guys. Hopefully this works this time. I'm going to go slower and smoother and faster. What? So if I were to factor this, what this is telling me, you don't need to know this, but it'd be x plus 1 squared. Like if I were to factor it. It means that 0 is in there twice. It's hiding. It's being a sneaky snook. So that means if negative 1 is a 0 twice, do I have to list it twice? No, this is just a unique case. I like it because we have to do that method twice, though. So we get to see it twice. And then this is x squared, x, and 1. What do I do? What do I do with this part once I have my real zeros? What would I do with it? Set equal to 0. I warned you guys, you're not going to have enough room to write this stuff today. I learned this when I was a freshman teacher. All right. I would quadratic it, right? We might as well finish it because we got to finish strong. A wise person once. All right. Mid-Mich is also a good college. So I did the quadratic, right? So I get 4 plus or minus square root of 20 over 2. So that's 2 solutions, right? Now, on the homework, what are you going to need to do? Plug in your calculator and get decimals, right? You have to do the adding and subtracting. And my other 0 is negative 1. And now many people may say, but Mr. Terwilliger, that's actually the fourth. Shouldn't we get 4 solutions? Didn't we? -1 occurred twice. All right. All right. That was a lot. That's it.